3 weeks ago, Jensen Huang stood at the Financial Times AI Summit in London and said something that sent shockwaves through Silicon Valley. China is going to win the AI race. Not might win, will win. The man who built a $5 trillion empire on GPUs just told the world that his own technology is about to become obsolete. And he's right. Because while Washington was busy writing sanctions, Beijing was solving problems that Western scientists abandoned a century ago. This isn't about stealing technology. This isn't about copying chips. This is about China inventing an entirely new way to compute. And here's the craziest part. This isn't built on a 399 node. It's built on old manufacturing tech, the kind the US didn't even bother sanctioning. A method so radical, so fundamentally different that it makes digital computing look like we've been using typewriters in the age of AI. Today, I'm going to show you exactly how China cracked the analog code, how they achieved precision that was considered physically impossible, and why this changes everything about the future of AI, 6G networks, and global tech power. Before we had binary computing, before zeros and ones, humanity tried a different path. Analog computing. Instead of breaking reality into discrete bits, analog computers processed information as continuous electrical signals, like how nature actually works. The problem: noise, drift, imprecision. Every analogy computer built in the 1900s suffered from the same fatal flaw. They couldn't maintain accuracy. A calculation that started precise would become garbage after a few iterations. Digital computing won because it was stable, predictable, reliable. For 100 years, engineers assumed analog computing was dead, a historical curiosity, a failed experiment. Then, on October 13, 2025, researchers at Peking University published a paper in Nature Electronics that broke physics as we know it. The title? Precise and Scalable Analog Matrix Equation Solving Using Resistive Random Access Memory Chips. Translation: we just made analog computing more accurate than digital computing while making it 1,000 times faster and 100 times more energy efficient. This isn't an incremental improvement. This is reinventing the entire foundation of how computers work. Let me explain what they built, because this is genuinely mind-blowing. Traditional chips, the ones in your phone, your laptop, every Nvidia GPU, work in binary. Every calculation is broken down into billions of on-off switches. A transistor is either conducting electricity or it's not. 1 or 0. But here's the bottleneck. Your data lives in memory and your calculations happen in a processor. Every single operation requires data to travel back and forth between these two places. This is called the von Neumann bottleneck, and it's the reason your GPU consumes 700 watts of power to train AI models. China's analog chip solves this with RRAM, resistive random access memory. Instead of storing data in one place and processing it in another, RRAM does both in the same physical location. Imagine if your fridge and stove were the same device. Food goes in raw and comes out cooked without moving an inch. That's what in-memory computing does. But here's where it gets insane. Instead of binary, 1 or 0, RRAM stores data as resistance levels. A single memory cell can hold not just 2 states, but hundreds of different resistance values. It's like having a dimmer switch instead of a light switch. When you run a calculation, electrical current flows through these cells. The resistance determines how much current passes through. And because you can precisely tune each cell's resistance, you can perform massively parallel computations, all happening simultaneously in the same hardware where the data is stored. The result? The researchers achieved what they call 5 orders of magnitude improvement in analog precision. That's 100,000 times more accurate than any analog computer in history. So how does this compare to Nvidia's best? The Peking University team tested their chip on matrix equation solving, the foundation of AI training, signal processing, and scientific computing. 1,000 times higher throughput than an Nvidia H100. 100 times better energy efficiency. Accuracy equivalent to 24-bit fixed-point digital systems. These are early lab benchmarks. Real-world performance will vary, But even a fraction of that improvement is enough to reshape AI hardware forever. And unlike experimental chips that live forever in research labs, this chip was manufactured using commercial production processes, meaning it can be mass-produced today. Now here's where this story gets really interesting. US chip sanctions were supposed to cripple China's AI ambitions. Since 2022, Washington has banned the export of advanced GPUs to China. No H100s, no A100s. The goal was simple: starve China of the computational power needed for cutting-edge AI. But Jensen Huang warned this would backfire, and he was right. In November 2025, at the Financial Times Summit, he said, "China is going to win the AI race because of lower energy costs and looser regulations." He criticized Western cynicism and warned that cutting off China's access to Nvidia chips would only accelerate their domestic innovation. The data proves him right. Research published in 2025 shows that US sanctions stimulate innovation in Chinese companies. After being placed on the US Entity List, Chinese tech firms receive increased government subsidies, attract more investment, and double down on R&D. Huawei is the perfect example. After US export controls, they developed their own operating system, built their own chips, and actually increased their global market share in telecom infrastructure. The sanctions didn't kill Chinese innovation. They redirected it into entirely new computing paradigms that don't rely on Western technology at all. Real quick, if you're following the chip wars and want to understand what's really happening behind the headlines, hit that subscribe button. We're the only channel connecting deep tech breakthroughs with geopolitical strategy. New videos every week breaking down the technologies that will define the next decade. All right, back to the story. So what can you actually do with an analog chip that's 1,000 times faster than a GPU? Application 1.1. 6G networks. Next-generation wireless networks will use massive MIMO antenna arrays, hundreds of antennas processing signals simultaneously. The math required for this is insane. Current digital processors can't keep up in real time. Analog RRAM chips can handle massive-scale signal detection with ultra-low power, enabling true 6G base stations that don't require entire power plants to operate. Application 2. AI training. Training large language models like GPT requires enormous matrix multiplications. This is exactly what analog chips excel at. The Peking University researchers specifically optimized their design for second-order optimization algorithms, the cutting edge of AI training. Imagine training the next GPT model in days instead of months, using 100 times less electricity. That's what analog computing enables. Application 3. Edge computing. Here's the game changer. Because these chips use so little power, you can run AI inference and training directly on devices. Your smartphone, your car, medical wearables, drones, no cloud connection needed, no data leaving your device. Fully autonomous AI that learns and adapts locally. And China isn't waiting. ChipX, a company that has developed a photonic chip, is already producing 12,000 wafers per year. Their technology is deployed in aerospace, biomedicine, and finance. This analog RRAM breakthrough is following the same path. The research is done. The manufacturing process is proven. Now it's a race to scale. But there's a deeper story here that nobody's talking about. The AI race is actually an energy race. Jensen Huang said China will win because of energy costs and subsidies. Let me show you what he means. In the US, electricity prices are surging. AI data centers are straining the grid. Energy is becoming the bottleneck for AI development. Meanwhile, China is offering massive power subsidies to tech companies, cutting energy costs by up to 50%. They're building AI-ready power infrastructure at a pace no other nation can match. The result? Chinese tech companies can train AI models with subsidized electricity, but only if they use domestic chips. Today's AI runs on GPUs that burn a small city's worth of electricity. Tomorrow's AI could run on a chip the size of a fingernail that sips power like a light bulb. And now, with analog chips using 100 times less power than GPUs, China's energy advantage becomes even more devastating. This is why analog computing is such a strategic breakthrough. It's not just faster, It's efficient. It turns electricity into computation at a rate that digital systems physically cannot match. So where does this go from here? The Peking University researchers are already planning the next generation. Larger, fully integrated chips, better calibration algorithms, enhanced precision circuits. They're targeting full-scale deployment in telecommunications, AI training platforms, and scientific computing clusters. But here's the question that should terrify Silicon Valley. Can Western chip companies catch up? The honest answer? They're not even trying. While China solved a century-old problem in analog computing, US companies are still iterating on digital architectures that hit fundamental physical limits years ago. Nvidia's roadmap is more transistors, bigger GPUs, higher power consumption. Intel is struggling with 18A node manufacturing. AMD is playing catch-up. Nobody in the West is pursuing radical new computing paradigms like analog or photonic systems at scale. We're watching a fundamental divergence in technological philosophy. The West is optimizing yesterday's technology. China is inventing tomorrow's. And the gap is widening fast. This is the moment historians will point to. October 2025. When China proved that analog computing, written off as impossible for 100 years, is not only possible, but superior to the digital systems that defined the last 5 decades. The GPU era is ending. Not because GPUs became obsolete. They're still essential for graphics and certain parallel tasks. But for the computational heart of AI, for the massive matrix operations that power every neural network, analog and photonic architectures are the future. Jensen Huang saw it coming. He warned Washington. He told them that sanctions would backfire, that China would innovate around restrictions, that the real race was for energy and developers, not just silicon. Nobody listened. And now China has built chips that don't need TSMC's 3-melon process, don't need ASML's EUV machines, don't need American GPU architecture. They rewrote the rules of the game. If you want to understand what happens next, how this affects TSMC, ASML, the semiconductor supply chain, and global AI leadership, you need to be subscribed to this channel. We're tracking every development in the chip wars, every breakthrough in computing, every shift in the technological balance of power. Hit subscribe, turn on notifications. Because the next decade of computing is being written right now, and the story is moving faster than mainstream media can keep up. I'm Quantum Silk Route. This is where future tech meets global power.